Greetings. In this video, I'm going to discuss discrete random variables. So let's start with talking a little bit about what I mean by a random variable. A random variable is a variable, obviously, with value determined by chance. Oh, I want to say here with numerical value determined by chance. And so determined by chance, what I mean there is by a probability experiment. So random variables can be either discrete or continuous. So discrete would mean there are finite or countable values that the random variable can take, and continuous would mean that there are infinite values that the random variable could assume. So we can talk about also the probability distribution for a random variable. So for a discrete random variable, since there are a finite number of values, we can, so this would be a probability distribution for a discrete random variable. This would be a list of the possible values together with each probability. So for example, let's say that we have a random variable, and just like in algebra, we often use letters to denote a random variable. However, we will use a capital letter in probability to discuss a random variable. So for instance, x. So if I want to define this discrete random variable x, and to say that its value is determined by the roll of a die. So I know that the possibilities are 1, 2, 3, 4, 5, and 6, and the probabilities are 1/6, 1/6, 1/6, and so forth for each of those values. So this is the probability distribution for the discrete random variable x with value determined by the roll of a die. If you want to check the validity of a probability distribution, there are two things that you can check. First of all, each of your probabilities should be between 0 and 1. And notice all the probabilities here of 1/6, those are certainly between 0 and 1. And secondly, if we add up, so that's the Greek letter sigma for summation, if you add up all of your probabilities, you should get exactly 1. And notice if I total this column of values, I would get exactly 1. So another something that is often of interest to us with a random variable is to know, over time, this random variable x, it will assume different values. So if I roll a die once, the value of x may be 3. If I roll the die again, it's going to change the value of the random variable maybe to 5. And so each time I roll the die, the random variable takes on a new value. So maybe 1, maybe it's 1 again, 6, 4, 2, 3, and so forth. Imagine that I do this many times. Maybe I can repeat this, infinitely many times. What I'd like to know is if I took the average, and by average I mean the mean, so where I add up all these values and divide by how many I have, what would I get? So in this case, you might intuitively see that since I have the possibilities are 1 through 6, and each of those is equally likely, I would expect the mean in the long run to be somewhere in the middle of those values. And in fact, it would be right in the middle, so at 3.5. So I'll show you in a minute how we can actually calculate that. But so that would be the mean, so we're using the symbol mu. I'm using a subscript here of x to indicate that this is the mean of the random variable x. And I'm using mu rather than x bar because here, I mean, it's the long run average, if I could do this many times or infinitely many times, as opposed to if I were to only roll the die maybe this many times and then quit. I could still take an average, but that would be a sample average. So with the ... I'm meaning that happens many more times. So the long run average here would be 3.5. Sometimes we call this the expected value of x, in which case you would use the notation E with a set of brackets with the name of your random variable inside. And by the way, you don't have to use x. You could use a capital Y or some other capital letter, but I'm just using kind of the generic x here for my random variable. So that the expected value gives us some idea of what would be typical for an outcome. But notice, if you were to roll the die any one time, you could never get a 3.5. So our random variable x is never going to actually assume the value of 3.5. So that would be the long run average of the values that it would assume. So recall that to go with any measure of center, it's nice to have sort of a measure of spread. And the partner for the mean is the standard deviation. And we'll use the symbol sigma for population standard deviation. And once again, I'm going to put a little subscript of x there. So this would be the typical deviation from the mean. So let's look at how we can calculate these two things, the mean and the standard deviation for a random variable. And I'm going to use this example. It makes the calculations easy. So let me go over to another sheet of paper and actually going to copy down that probability distribution once again. So here are my values of x and the probability for each. So to calculate the mean, I want to add another column where I take each of these values, x, and multiply it by its probability. So I'm multiplying across each row. So 1 times a 6 is just a 6. 2 times a 6 would be 2 6, and so forth. I'd have 3 6, 4 6, 5 6, and 6 6. So once I multiply across, I'm going to total this column. And luckily I've left everything with a common denominator, so that makes this easy. I want to have something in terms of 6. 1 plus 2 is 3, plus another 3 is 6, plus 4 is 10. That adds up to 21 over 6, which reduces or simplifies to the decimal 3.5. And notice that's what we kind of said intuitively we thought the mean would be, right there in the middle. So, but this is the calculation that would work for any probability distribution for a discrete random variable. I also want to show you how you could do this in your calculator. So I'm going to go to my stat list and clear each of these things out. and then type in the values 1, 2, 3, 4, 5, and 6. And then 1 divided by 6, 1 divided by 6, and so forth. So, in order to do the multiplication across, I'll move my cursor over and up so that the column header is actually highlighted. And notice that I have an equal sign here, and so I can type in L1, so I hit the second key and then the number 1, and so that says L1 times L2. And when I hit enter now, we're going to see it in decimal, but that's the equivalent of what I was doing by hand here to get the 1626 and so forth. So now I need to add up those values in order to get this answer. So in the calculator, I'm going to exit out of my list menu and go to the list screen by hitting the second and the stat button. And so I want to scroll over to the math options, and notice that number 5 says sum. So I want to select that, and now I'm back at my home screen with a parentheses started. I want to sum the values in list 3. So I notice you get 3.5, the same thing we got by hand. So that's how we can get the mean for the random variable x, either by hand or using a calculator. So let's hold off until the next video, which will be short, and then I'll show you how to calculate standard deviation.